All right, here is homework 1 solution, which is our review of resolution proof for first order logic. And this is a homework problem from Nilsson's artificial intelligence book. And Quinn and Alex and Blake are members of the Alpine Club. Every member is either a skier or a mountain climber or both. No mountain climber likes rain. All skiers like snow. Alex dislikes whatever Quinn likes and likes whatever Quinn dislikes. Quinn likes rain and snow. So the question is, who's a member of the Alpine Club who is a mountain climber but not a skier? And we can use resolution proof to see who this is. So the first thing we need to do is we need to represent these sentences in first order predicate calculus or first order logic. First one's pretty easy. Quinn, Alex, and Blake are members of the Alpine Club. And remember that a predicate has to be true or false. And it is true or false that someone is a member of the Alpine Club. So the predicate is member. And Quinn, Alex, and Blake are constants. So we can simply represent this sentence as a conjunction with the predicate member and the arguments to that predicate Quinn, Alex, and Blake. The next sentence is every member of the Alpine Club is either a skier or a mountain climber or both. So obviously we're going to reuse our member predicate. We need two new predicates, one for skiers and one for mountain climbers. And notice that it says that every member of the Alpine Club. So this means we're going to use a universal quantifier. And we get for all x. If x is a member, then that implies that x is a skier or a climber. The next sentence, and I've broken this up, no mountain climber likes rain, and we're going to use our mountain climber. Now we need a new predicate called likes. So it's true or false that you're a mountain climber, and it's true or false that you like rain. And since this is no mountain climber, that means it is true for all mountain climbers that they dislike rain. So we can write this as for all x. If x is a climber, then it implies that x does not like rain. And so we can use the negated predicate of likes. All skiers like snow. This is a little straightforward because we don't have to worry about all versus no. So if you are a skier, then that implies that you like snow. Now our next sentence, and I've broken this up also, Alex dislikes whatever Quinn likes. Maybe another way to think about this is whatever Quinn likes, Alex dislikes, and this is true for all things that Quinn likes. So we can use for all things that Quinn likes, that implies that Alex does not like it. And then the second part of that sentence is Alex likes whatever Quinn dislikes. So if there's something that Quinn dislikes, that means that Alex likes it. So for all the things that Quinn dislikes, that implies that Alex likes it. This is an easy one. Quinn likes rain and snow. So Quinn, rain, and snow are just constants to the predicate likes, and it's a conjunction since Quinn likes both rain and snow. And then our conclusion or our question is, who is the member of the Alpine Club who is a mountain climber but not a skier? And that means that there must exist some member. And so we can write this as who is the member who's the climber but not the skier. So the next step is we have to convert all of these sentences to clausal form. Just remember very quickly that the first step is eliminating implications. Then we move negations into atomic formula. We standardize existentially quantified variables. We eliminate existentials by introducing either Skolem constants or Skolem functions. We drop universals. We distribute. We write in clausal form, and then we rename variables. And depending on the clause we're rewriting or the sentence we're rewriting, we may or may not use all of these steps. So let's convert this first one to clausal form. It's an easy one. So remember, we had the conjunction, member Quinn and member Alex and member Blake. It's already in conjunctive normal form. So we can just convert that into clausal form and we get 3 clauses. The next one is every member of the Alpine Club is either a skier or a mountain climber. First thing we have to do is eliminate the implication. Notice that the scope of the universal quantifier is the entire implication. So when we negate the antecedent of the implication, it's the negation of the member predicate. And then we convert the implication to disjunction. Now at this point, we can drop the universal quantifier. Now we have something that is in conjunctive normal form, so we can write that in clausal form. And then finally, we rename the variables. And since this is the first time we've renamed variables, we can just use 1 as the suffix for our variables. The next one is no mountain climber likes rain. Again, we have an implication that we have to eliminate because the scope of the universal is the entire implication. When we negate the antecedent of the implication, we negate the predicate climber, and then we can convert the implication to a disjunction. So we get this. Now we can drop the universal. We have something in conjunctive normal form, so we can convert that to clausal form. Now we rename our variables. Since we used 1 previously, we can use 2 here, and now we have unique variables. All skiers like snow. We have another implication. Scope of the universal is the entire implication, so we negate skier, convert the implication to a disjunction. We can drop the universal, write this in clausal form, and then rename the variables, this time using x3. Alex dislikes whatever Quinn likes. Again, we have an implication. When we rewrite that, we negate the predicate likes, the first one. Now we can drop the universal quantifier. We have something in conjunctive normal form. We can write that in clausal form. We rename the variable to x4. Another implication. Scope of the universal is the entire implication, so when we eliminate the implication, we negate the negated predicate likes, convert the implication to a disjunction. Now we need to move negations to atomic formulae, which means that we eliminate the not, and we have a disjunction at this point. We can drop the universal, convert to clausal form, rename the variables using x5. This is an easy one. Since we have a predicate with constants and it's a conjunction, the only thing we have to do is convert it into clausal form. Now our conclusion, first thing we do is we negate it. We negate the entire conclusion. So the negation goes to the left of the existential. There are no implications to eliminate, so we need to move the negation into atomic formula. When we bring the negation across the existential, it converts it to a universal quantifier. Now we're negating the entire conjunction. We move the negation in, and using De Morgan's law, we convert the conjunction to disjunction and negate the terms. You notice that we have not skier. So when we remove that negation, we now have for all not members X or not climber or skier, we can drop the universal now. We have something in conjunctive normal form. We can write that in clausal form, and now we rename the variables. Okay, now we are ready to do a resolution proof. I've listed the premises and the negated conclusion here on lines from 1 to 11. And the first thing I'm going to do is I'm going to resolve lines 7 and 10. So on line 7, I have my likes clauses here. And on line 10, I can resolve with likes, and X4 binds with snow. I substitute that back in to not likes Alex and X4, and then that gives me my resolvent, which I add to my list of clauses. Next thing I do is I'm going to resolve 6 and 12. So 6, and then on line 12 is the resolvent I just produced, and so I can resolve on likes and not likes. X3 binds with Alex, and then I substitute Alex in for X3, and I get not skier Alex. Now I'm going to resolve 4 and 13 on skier. So X1 is going to bind with Alex, and then I substitute X1 or Alex for X1 in the remaining predicates, and I get not member Alex climber Alex. Now I can resolve 2 and 14, so member and not member Alex, and that leaves the predicate climber Alex. So I have an empty substitution list. Now I'm going to resolve 2 and 11. So that's going to resolve on member, that binds X6 to Alex, and then I substitute in Alex for not climber and skier, and that gives me 16. Next, I'm going to resolve 13 and 16, not skier Alex with skier Alex, and not climber Alex is left over. And finally, I can resolve 15 and 17 with an empty substitution list to derive the empty set. And so therefore, my conclusion is that Alex is a member who's a climber, but not a skier. So the question is, well, Alex is a member who is a climber, but not a skier, but what about Blake, and what about Quinn?